Let's jump right in. Today we're unpacking a really high-stakes topic in gas carrier engineering, the safety chemistry of chlorine and ammonia. Now, on a traditional fuel gas leak, your first warning is usually that recognizable smell of hydrocarbon, right? You've got seconds, maybe even minutes to react. But on a toxic chemical leak, the rules of survival completely change.
Okay, let's dive into this because we really need to shatter a baseline assumption here. Most people just assume you can smell a gas leak in time to escape. And, with hydrocarbon leaks, your nose is actually a pretty decent early warning system. But with chlorine leaks, by the time your brain even registers the smell, the gas can literally incapacitate you within the very same breath you use to notice it. You get absolutely zero warning.
To understand exactly why this happens, we have to talk about the threshold limit value, or TLV. Basically, this is the maximum concentration of a chemical you can be exposed to without adverse health effects. Think of it as the absolute ceiling for safety. And looking at this is going to show us just how shockingly little of these toxic gases it takes to cross the line from completely safe to lethal.
0.5. That is chlorine's toxic threshold limit value. Just 0.5 parts per million. That's a concentration so incredibly low, you can receive a dangerous, life-threatening dose way before you can even smell it clearly. So what does this mean for crews? Well, it means on a chlorine cargo watch, you absolutely do not wait around to smell something wrong. You have to rely entirely on fixed and portable gas detection systems. Because, let's face it, human senses are a completely unreliable warning system for this stuff.
Act 1. Chlorine's deception.
So while chlorine is obviously dangerous to us humans, it has this secret deception that targets the physical pipework itself. And here's a twist that surprises a lot of people. Pure, dry, liquid chlorine isn't actually that corrosive to standard steel piping. You can pump it safely. But the danger switches on the absolute instant moisture enters the system. The second chlorine mixes with even a tiny bit of water, it forms highly corrosive hydrochloric and hypochlorous acids. And those acids will rapidly destroy the steel containment system.
Because of this massive acid risk, maintaining the integrity of a chlorine system is a super strict moisture exclusion discipline. Crews have to follow these rigorous steps. Number 1, ensuring perfectly dry seals. Number 2, performing dry nitrogen purging. And number 3, executing a strict line drying protocol before any chlorine transfer even happens. It is all about keeping every single trace of water out of that system.
So, quick check based on what we just covered. Is dry liquid chlorine corrosive to a standard steel tank? The answer is no, not significantly, as long as it stays perfectly dry. The real enemy of the pipework isn't the chlorine itself, it's moisture contamination. That's exactly why moisture control is literally the single biggest operational discipline on a chlorine carrier.
Act 2. Ammonia's deception.
Let's pivot to ammonia. It's a heavily transported liquefied gas with a boiling point of minus 33 degrees Celsius. And much like chlorine, it brings some hidden hazards that can catch people completely off guard. The first one is materials compatibility. Ammonia aggressively attacks and destroys copper, brass, zinc-based alloys, and galvanized surfaces. What that means in practice is that every single valve, gauge, and fitting in an ammonia system has to be made of steel, aluminum, or another compatible material. Putting just one mistakenly placed copper gasket in an ammonia line isn't just a minor error. It is a slow, toxic leak just waiting to happen. Now, what's really interesting about this slide is the second deception. Most people think of ammonia purely as a toxic exposure risk, but guess what? It's also flammable. It burns within a very narrow band of about 16 to 25% concentration in air. Sure, it's a narrow window, but it is a very real fire risk. This specific deception has caused catastrophic accidents, basically catching crews completely off guard because they treated ammonia as just toxic and totally ignored the fire hazard. So, bringing this all together, we're looking at two totally different chemical cargoes that require two completely different watch-keeping disciplines. Chlorine's primary danger is its near undetectable toxic threshold, paired with a secondary hazard of moisture-triggered corrosivity. Ammonia, on the other hand, shares that primary toxic threat, but pairs it with a severe material incompatibility for copper alloys and a genuine, albeit narrow, flammability risk. Up to now, we've seen how chlorine and ammonia are dangerous because of what they do to your body and your pipework. But that leaves us with a fascinating and honestly slightly terrifying question. What happens when a cargo's biggest threat is actually itself? In part 2 of this explainer, we're going to look at reactive chemicals that undergo uncontrolled polymerization, stuff like ethylene oxide and VCM, and a specific ammonia failure that physically chokes safety valves closed, known as a carbamate blockage. It's wild, and you definitely won't want to miss it. Thanks for hanging out with me today, and I'll catch you in the next one.